Okay, we want to look at the solution of the differential equation, y prime equals x squared plus y over x. The equation that we solved with some errors numerically in class. Using my mental calculations, I made a couple of errors as expected, but the process should be very clear. Let's translate the process over. Okay, we get to share a screen here, and so to do it. Okay, now I've set up parts of the spreadsheet. Simply going to use H for my increment, and for the first approximation, the increment was 0.5. X naught is 1, Y naught is 1 for this approximation. So N is going to be the number of my step, and N is going to be 0, 1, and then we can grab this and use the fill handle to fill this down as far as we like. Now, my first approximation, well, let's go on down to the 10th step. Okay, now at step 0, we're going to have x naught equals 1, y naught equals 1. So x will be 1. And I'm not going to put in 1. I'm going to put in equals this. Okay, and y. Didn't seem to like this. X equals D4. Okay, I must have clicked on something I didn't intend to. And y equals 1. Okay. Now we want to fill in our calculation scheme. So f of xy is what? Now remember that the equation is y prime equals f of xy, which equals x squared plus y over x. So f of xy is going to take the value of x and square it. It's going to take the value of y and divide by the value of x, and it's going to add those two. So I just put in here, this is equal to this squared plus this, the value of y, divided by the value of x. And of course, that's 2 easily calculated. Besides, we've seen that on the video. Now, our x increment is going to equal this. Now, this time I have to be careful because the x increment is going to be dragged down. Okay, we'll see what that means in a minute. But this means I've got to put a dollar sign in front of b and a dollar sign in front of 2. My y increment is going to equal slope times the x increment. And we saw geometrically why that's so. And the slope is f of xy multiplied by the x increment. In this case, in the first step, that's 1, and we saw that. So the new value of x is going to be what? It's going to equal the old value of x here. And we better put an equal sign there, so it grabs this, plus the change in x. The new value of y is going to equal the old value of y plus the change in y. Okay, now these numbers all agree with our first estimate. Now we go down to the second estimate, and x is going to be our new x, and y is going to be our new y. Now f of xy, well, if I take this cell and drag it down, it's going to give me my next value of f of xy because look here, this did the calculation, negative h4 squared plus I4 over h4. Well, here's h4, we square this, and then we do minus this over this. h4 is the x value, which that's our x squared, and then I4 divided by h4 is our y over x. So that's going to be our f of xy. That's going to be our new slope. Now dx, our value of x, we simply drag this down. I had the dollar signs on the 0.5. Well, the dollar signs on the reference back to this cell, which means that when I drag this down, it's not going to change. Then my dy, I can simply drag this down, because now this one calculated the slope times the x increment, slope and x increment being in J4 and K4, and we see that that involved J4 and K4. And then here, something happened here. So I did something careless. I've got to, this is going to be equal to the slope times the change in x. And if I hit the asterisk instead of the parenthesis, that'll be right. Now, if I drag this down, then what do I have in this column? I have J5 times K5, which is, of course, here's J5, here's K5. Just like in this cell, I had J4 times K4. Well, here's J4, here's K4. The value of f of xy, the slope, multiplied by the x increment. Okay, now my new value of x, well, I don't have to type it in. I can drag it down here, and it's going to add my change in x to my old value of x. By cell reference, we see the cells, this cell and this cell. And that's going to be my new value of x. My new value of y, well, how did I get my new value of y? I added my old value of y, this I4, to my L4 to get my new value of y. And that was 2. If I drag this down, it'll take the I4 plus L4, and it'll become I5 plus L5. And it'll be adding the old value of y to the change in y. Now, I didn't have to do that one cell at a time. So I can wipe out all of these cells. Values. I can do all these cells at once. Now that I've done that, I've got my rule where this cell copies this cell copies this cell, and all of these cells will do what they did before, except with the values in the new line. So it's all set up, so I can just drag it down and get my estimate for x equals 2. And then if I want estimates up to x equals 10, there they are. I don't really care about the estimates past 2 because we're just checking this against the previous results, but I'm going to copy a few of them. So x values, over here for 1, 1.5, 2, 2.5, 3, that's plenty. except, yeah, no, I don't want to go out to 10. Okay, now the y values with 5 are about 3.79, 6.74, 11.2, and 17.6. Just, okay, and we have one more. And then we have 26.2. Okay, so these are the y values that I estimate with increment 0.5. Okay, now my y values with increment 0.1. Well, all I have to do now is change this 0.5 to 0.1. And look what happened. All these numbers changed. Okay, now we see that when x is 1, my y value, and you know what I did? I copied down the wrong y value. So I'm just going to press Control Z and get back to my values. Got to go back here. When x is 1, y is 1. When x is 1.5, y is 2, because my x and y values are right here. Now you wonder why I didn't just copy these over, because when I change my value of h, they're all going to change. And if I copy these over to here, they're all going to change too. Now there's a way to get around that, but we're not going to mess with it. And then when x is 2, it looks like here y is 3.79. Okay, when x is 2.5, y is 6.74. And when x is 3, y is 11.2. Just using 3 significant figures, it'll be enough for most of our purposes. Okay. Now, if I want to do this with h equals 0.1, and I'm going to do that, there it is. Now, if I wanted to keep my values here, I could have just copied this whole thing, except I've had to be careful. Remember, I seeded this thing with the x value here and the x value here. This x value was done by straight cell reference, and I want to hold the contents of that cell constant. So if I did want to copy this set of calculations down to another place, well, actually it wouldn't work, but okay. I'm gonna just, out of precaution, because these values are not going to change, I'm going to put dollar signs here. There's another thing wrong with what I just said, but you get some idea of what you can do with Excel. I never use the thing, so I hadn't looked at Excel for probably a couple of years before we did this in class, but it's all pretty obvious. Okay. Now, I've changed h to 0.1. Now, what's my value of x when y is 1? Well, it's still 1. Sorry, what's my value of y when x is 1? Okay, doesn't matter what increment I use, these are going to always be the same. I could change them. You know, I could change my conditions. I could change this number and or this number and get a different curve. Okay, now at 1.5, see, we've got 1.5, 2.33. Whoops, 2.33. And then when x is 2, looks like y is up to 4.71. Now, if I want more values, well, I'm going to have to drag this down a little further. Drag it down about 10 more. Okay, so when x is 2.5, y is 8.52. And when x is 3, y is up to 14.13. Now, when I did this in class, I got contrary results that seemed to contradict what I'd said in class about the way these graphs are going to diverge and that the graphs would all be underestimates. So apparently I did something wrong with the spreadsheet last time. So I don't know what that might have been, but I'm not going to worry too much about it. Okay, now, if I want H to be smaller, and let's see, if I let H be 0.1, then I'm going to have 200 rows here. Yeah, I said 0.1, 0.01. Okay, if H is 0.01, you notice that my X value has only gotten up to 1.21 here. So I'm going to have to drag this down until I've got 50, actually 51 lines of the calculation. So here we are. Now here I've got X equals 1.5, and I see that Y is 2.43 if I round it off. So we get a 2.43. We notice that the estimate between Y increment of 0.5 and increment of 0.1 changes by 0.33. If we go from increment 0.1 to increment 0.01, the estimate only changes by 0.1. Okay, so we have a much bigger change between these values than we do between these values. Now, if I want my estimate for 2, and that's as far as I went with the table on the board, and that's as far as I want to go here. I can drag this down until I've got 100 and some lines, so that I know that I have 100 increments of 0.1, which gives me an increment of 1 starting at 1. So I've got 2 and I've got 4.97. So I'll come back up here and I get 4.97. Now, once again, in going from 0.5 to 0.1, and the increment only got 5 times shorter, I had a correction of almost 1 in the value. The distance between here and here is about 1. Okay, the increase from here to here is only about 0.3. So that's kind of consistent with what we saw here. This increase was about 3 times this increase, and the increase from here to here is about 1/3 of the increase from here to here. And we could continue on with this, but this demonstrates what I illustrated or what I said in class. Now, I said later that the results I was getting seemed to contradict that, and I couldn't figure it out. If the graph is concave up, then we're always going to be underestimating the change in Y, because the average value of Y prime between, say, this value of X and this value of X is going to be less okay, the average value of the change between rate of change between here and here is going to be greater than this because the rate of change keeps increasing. We see the rate of change here is 2.12, now it's 2.15. And that means that the estimate we made by assuming that the rate of change stayed at this value, the change in Y is going to be an underestimate. If we wanted a more accurate change in Y, we would find a way to calculate the average rate of change between here and here. Now, that average is going to be pretty close to the average of these two values, and that gets us into what we call a predictor corrector method. We could make the method a little more complicated. At each step, we could estimate what the rate of change is going to be at the next step, or what the change is going to be at the next step. And we could take the coordinates that we get from that estimate, and then we feed them back in here, but we use averages. I'm not going to go over it, but it's a very simple idea, very simple to implement, but a little more complicated if you're trying to do it with Excel. And I don't like Excel. I prefer just to write a program. And it's very easy to do that. It's a very simple method. Okay, well, anyhow, there's a demonstration of how we can use Excel to do this. Now, one thing we can do now is I can take, well, let's just take the Y versus X lines and make sure I've got X and Y here. And then I can highlight these columns, I hope. And I can highlight them all the way down to here. And then I can copy them. And then I can paste them here. Then I can go up here and insert a scatter graph. I call them charts, but I guess that's an okay term. Okay, right there is a chart that shows me these values. Now, I really don't much like the values I'm seeing, so I'd like to format this x-axis, and Excel doesn't seem to want to let me do that. Dealing with a new version of Excel. And if I right click in the right place, it would work. I think, really what I want to do is I want to format the axis. There we let us do it. Okay, I want to format the axis to go from a minimum of, oh, phooey. I thought I had X and Y. But it looks like I got N and Y. How did I do that? Anyhow, I'm going to take this chart and I'm going to highlight the chart and hit the delete key. It should go away. Now, what did I do? These are my values of X and Y. So why did they copy over here the way they did? Well, I guess I really didn't need to copy them. I can just do this using the keyboard so I don't have to rely on the mouse. Okay, let's try it again. I can insert a chart, graph here, and right there's my curve. You notice the curve starts at the point 1, 1, and it's concave up, and its values follow the values that we've calculated here. Now, if I solve the differential equation and compare the solution with if I graph the solution, the graph is probably going to be very close to the graph here. If I wanted to add the values that I got up here to the chart, it'd be a little more complicated. I could do it. I could get a graph that shows all three approximations. Not going to do that. Let you do that by hand, and let you do that using your graphing calculators or an online graphing calculator, some kind of an online computer algebra system, whatever you have available to you, and whatever you prefer to use. Okay, well, that's how we do this with Excel. Did it much more quickly in class, but apparently I made some mistakes. So it might be a good thing. It might be a good thing if I didn't have the recording on when I did that. Okay. Anyhow, we'll add this recording, either add it to the end of the video or in a separate video. Okay, stop the